Okay, well, let's go ahead and take a look at how to solve these quadratic equations. They're quadratic because their highest power on a variable is to the second power, but we're going to go ahead and solve them by the square root property. And I really want to take a look at one that has a perfect square in it first. So let me just write a problem here, and then it'll introduce what we're going to do from here on down. So for example, if I had x squared is equal to 9, we actually have two values that are possible to put in for x that when squared would give you 9. X could be 3 because 3 times 3 gives you 9, but x could also be negative 3 because negative 3 times negative 3 would give you 9. So when you take the square root of both sides to solve for x in a square root property problem, your answer has both a positive and a negative possibility. Now it turns out that this problem had a nice perfect square underneath this radical sign. But we could end up with problems like this one right here, where that is not a perfect square. So to leave answers in an exact form, we'll still take the square root of both sides, but leave it under the radical because the square root of 5 is irrational, meaning as a decimal, it never ends or repeats. It has a long, unrepeating pattern. And so we do get two answers, though. Again, we get plus or minus the square root of 5. So if the problems get any more involved, we're going to have the following steps to it. Let me actually take you right to a problem that has probably about as much as we're ever going to see in one of these problems in our course anyway. And so if we have a problem like this, what we're going to do first is isolate the squared part of the problem. So we would want to get rid of this 3, and because there's multiplication connecting 3 to the parentheses, our first step will be to isolate the square, and that's always going to be the first thing we make sure has either already happened or needs to happen. Isolate the square. And we're going to do that here by division. So I'll get x plus 2, the quantity squared, is equal to 12. Then what we're going to do is we're going to take the square root to get to the variable that is inside the square. And so we take the square root of both sides. And in this particular case, we would get this. Don't forget, we will have both plus or minus, because it's possible the amount under there when squared that gave me 12 could have been a positive or a negative version. And then we know that to square and take the square root, they're inverse operations, so we get just this base that was being squared. And then finally, what we do is we solve for x, if there's anything else to do to keep or to get x to be isolated by itself. So I'm just going to say we solve. And these are the steps of the square root property. And we're going to go ahead and subtract 2 here. And our answer is negative 2 plus or minus the square root of 12, which really does represent two answers. We have negative 2 plus the square root of 12 and negative 2 minus the square root of 12. Now, two things are going on there. Number one, we could leave it in this more concise form, but it really does represent two solutions. And number two, these things can be simplified. When we get to the next math class, 95, we'll learn how to simplify a radical. And even in our class, in Math 65, we could go ahead and take the square root of 12, get a decimal. But unless we have an application problem, which we're going to get to in another video, we would go ahead and just leave the answers like this for now, and we'll worry about simplifying further when we get to another math class. Let's just take a look at one more if we had a problem like this right here. So here, once again, following these steps up above, the first thing we're going to do is isolate the square. So I'm going to go ahead and add 5 to the other side. Then I'm going to divide by 3. And now I have the square by itself on one side. And what I'm supposed to do after that is take the square root, and we know, again, it's possible that a positive or negative version of the answer, when squared, gave me this. So when I take the square root, I want to say that x could have been plus or minus the square root of 5/3. And once again, in Math 95, I'm going to go ahead and be able to, I'm not sure if I showed the answer there. When I took the square root of both sides, I got plus or minus the square root of 5/3. But right here, at this point, I could simplify this in this radical form into a more efficient form, but I'll learn about that in Math 95, and we'll accept this as an answer in Math 65.